before we proceed, let's just introduce a technique that's used very frequently inside Houdini, which is copying things to points. I'm going to create a piece here, a piece of geometry. You have a collection of test geometry, so if you just type test, and we have a bunch of them. For now, I'm going to use the pig head. Let's have a look at that. So we have a pig head. We don't need it to be as highly detailed, so here on the difficulty, let's say easy, and that way it's just geometry, plain geometry, and very low res. The other thing I'm going to create is a plane or a grid. And a grid will have by default this amount of points. I just pressed Shift W to turn on the geometry. Let me hide the grid. And you can turn the points on and off. And the technique of copying things to points, you have several operators that can help you do that. But if you type copy, let's use the copy to points. And you have two inputs, the things that you want to copy and the points where you want to copy them to. So this is what I want to copy, and these are the points where I want to copy them to. And right now I have a bunch of big heads. Let's reduce the size of it. Say 0.5, just so we have a bit more room between them. This can work with a line, for instance. Right now we're using a grid, but you can use whatever you want. Let's say a sphere. You can use a sphere. Let's just make sure that our sphere is big enough that we actually have polygons on them. Okay, same thing. And if you notice, the orientation of each big head will kind of be aligning. Let's have a look at the axis. Notice that the big head is facing the z-axis. That's the axis that's going to be aligned with the normal of the surface. If we have a look at the sphere, or better yet, if we have a look at the grid, and if we have a look at the normals of the grid, we only have normals on the vertices, so let's create normals. And let's say we want to create normals not on the vertices, but on the points. And now we have the regular point normals. And you'll notice that our polygons, our pig heads, the z-axis of our original pig head is facing the normal of the grid. That being said, if we somehow change the orientation of the normal of that surface, we should change the orientation of the pigs on the copy to points. The copy to points don't have a lot of options. We do have these things. So this just means that if these attributes are available on the points, they will be transferred to the geometry that's being copied to that point. Right now, we don't have velocity or alpha. We do have normals, and they should be being copied to the pig geometry. We don't actually want any of this to happen, so let's just delete all these. Now, let's change our normal. The way we can change the normal is just by changing its value. Right now, if we have a look at the grid after we apply the normals, you'll see that, and you open the geometry spreadsheet. If you don't have it here, you can create another one here, geometry spreadsheet. And if we check it out, you'll see that all the points have the same normal, and all the normals are just 0, 1, 0, meaning they're facing up on the y-axis. Now, let's see if we can make it that the normal is not facing up, but it's actually facing forward. And that way, the pig head should remain with this orientation instead of all the pig heads being pointing up. So the way we can do that is by using a wrangle. A wrangle is where you can write a piece of VEX code, which is the code that's used for the code language that's used inside Houdini. And let's see how we can create just a little bit of code that's going to allow us to manually define the normal for each one of the points. Let's hit tab, type point wrangle, and this is going to run over each one of those points. They're going to be the way this is going to work is it's going to be very efficient because it uses multi-threading and it does parallel computing. So it's going to be running through different groups of points at the same time. Let me set it here. So the way we can control the attributes, or we can access or define an attribute, is by, in this case, the normal attribute is a vector. So let's say a vector attribute called normal is equal to, this is what this means. Vector attribute normal is equal to, and let's create a vector with curled brackets. And right now the vector is 0, 1, 0, but we want it to be facing the z-axis. So we want it to be 0, 0, 1. And each line of code needs to be terminating and needs to end with a semicolon. And now if you have a look at the vectors here, already this is looking weird because the normals of our surface have changed and they don't look natural at all. Okay, and you can clearly see the difference in the viewport. You can clearly see the difference here as well. So all the normal values, which were 0, 1, 0, are now 0, 0, 1. If we have a look at the orientation, so they're all facing this way, and that's the direction that the pigs should be facing now. Okay, so all the pigs are facing on this direction. Now, for us to have clear control over the direction which these pigs are facing, over the orientation of the pigs, we actually need two vectors. Right now we have a vector facing the normal. We're just using the normal, which is facing to the front. But this pig could be rotating, still facing the front, but rotating on every other direction based on that axis. And the way for us to control, the way we can control how the pig is oriented, not just facing, but in terms of the rotation along that axis, is by using a second vector, which is called the up vector. And as the name implies, the up vector is basically just us establishing what's the direction, in which direction is the y-axis of our object facing. And this means that, let's say, in this case, let's say we have our normals facing forward, and we want to create an up vector that should be perpendicular to this vector and facing some other direction. Let's use the same wrangle and say that, just for the sake of this example, let's say that we want the z-axis facing forward, the normal facing forward, and we want the y-axis of our pigs, we want them facing up, facing along the y-axis. And this should give us exactly the same result as we have here. So let's create another line of code where we type vector attribute called up, this time no caps, equals another vector that we want it to be 0, 1, 0, which is just facing up, pointing up, semicolon, enter. And as you can see, we have exactly the same result as before. But the difference is that now if we have a look at this, if we middle mouse button here, you'll see we have normal, position, and up vector of an up attribute. Let's have a look at this up attribute. We know we can see the normals here. And for us to see the up attribute, we need to control middle mouse button here, just to open this window, and just click on the vector, the attribute that you want to see displayed. There we have it. So these two vectors define the orientation of the object that's being copied to those points. If we change the orientation of the up vector, let's say we want the up vector facing this way. Remember, they need to be perpendicular to one another. So let's say we want the up vector facing this way. Our pigs should turn to the side as well. And that's going to be the x-axis. So let's say the up vector is actually 1, 0, 0. So the up vector is now facing this direction, and the pigs should be also facing that direction.